Hello, everyone, and thank you for attending today's webinar, Breaking New Barriers In-Call Speech Recognition Services Ready for Mass Markets, presented by Radisys and Strategy Analytics. I'm Kendra Chamberlain, and I'll be moderating this webinar. Just a few technical notes before we begin. If you'd like to download the slide deck, please click the Resources List button at the bottom of your screen. The webcast is being streamed through your computer, so there is no dial-in number. For the best audio quality, please make sure your volume is up. You can find additional answers to some common technical issues located in the Help button at the bottom of your screen. This webinar is being recorded and will be available on demand within 24 hours after the event. And we will follow the presentations with a Q&A session. Please submit your questions using the Q&A button on the left side of your screen. Okay, now let's begin. Sue Rudd, Director of Service Provider Analysis, Networks, and Service Platform at Strategy Analytics, will be leading the presentation today. Hi, Sue. Please go ahead.
Thank you very much. Good day. I'm Sue Rudd, Director of Network and Service Platforms for Strategy Analytics, and I'll be introducing the session with a market overview. That'll be followed by Al Belasco, the VP of Media Server at Radisys, and the challenges and opportunities for in-call advanced speech services, which is our major theme today. And then Adnan Salim, the CTO for Software and Cloud Solutions, will be introducing some very exciting real-world use cases. So please stay to the end because that's the most exciting part. I'm going to be talking today a little bit about how we got here. If you are not that familiar with the whole history of speech recognition, it began around the 1970s. We made major breakthroughs, and that's when IVR and PBX systems started to have spoken digits and select words for call center recognition. Seems like a long time ago. But that technology has evolved dramatically, and especially with the advent of handheld devices and smartphones, we started to see both network-based applications, not just server-based ones, and embedded speech applications in the devices where we had limited vocabulary that could be accessed on PDAs, the original personal digital assistants that preceded smartphones. But in the 2000s and late 1990s, we started to see some major changes that came along with the smartphone, and everyone is now familiar with the really easy-to-use user interface for speech on smartphones. But the next step that's been taken in the last 10 years or so has really been the evolution of natural language, which has been talked about for a long time, but we've made massive strides in the efficiency and accuracy of semantic processing in natural language. And that has been much assisted by machine learning and neural networks and a whole bunch of new technologies, which has led us to a speech recognition interface that's become a de facto user interface for a number of devices. And we'll talk a little bit about the hot markets that you all know. But what we found is those are very expensive. So we're going to be dealing with how can we bring these to a new mass market solution today. So let's talk about the hot markets that we've seen emerging. The most recent ones, which everybody's familiar with, are the Amazon Echo or Alexa, the Google Home Control. These are the things we've all probably got one in our houses at this point, and we may or may not use them that often. And usually they're pretty good for a very limited set of vocabulary capabilities. And then when we're mobile, we have the smartphone-assisted solutions like Siri. And then we have vocabulary and context-specific applications that are now becoming quite popular in surgery for a heads-up display for doctors to be able to request shifts in screens or look at different x-rays while they're operating with their hands, and similarly for vehicle navigation for hands-free applications. Strategy Analytics follows speech recognition growth in specific markets, the first of which is obviously the smart speaker section that we were just talking about. We estimate that market is now at about 100 million as of Q3 2018, but we fully expect this year a lot more ways in which these new smart speakers are going to unify in-home intelligent IOT devices and smart home ecosystems. The in-vehicle user experience group at Strategy Analytics tracks voice as the in-vehicle preferred mode for certain applications. And touch screens really never did take off, and the user interface has become the voice interface. So very important market for speech in vehicles, again, hands-free. And today we're going to be talking about some exciting examples for a market that it has multiple dimensions and will become a very important one, the voice-enabled IoT market, which we expect to be pervasive in consumer markets and probably to penetrate multiple enterprise segments. For consumers, we expect a lot of wearables, healthcare, smart home, consumer electronics, and smart buildings even. And then on the enterprise side, a lot of healthcare applications, transportation, rental vehicles, warehouse logistics, a lot of security and monitoring applications, and most importantly, industrial robotics and in-factory applications. So we're very conservatively estimating almost 400 million voice connections by 2025, and that is a preliminary estimate. We're probably going to be increasing that as we do more research. But an exciting new market for voice-enabled IoT, which brings the IoT applications through the telecoms network as appropriate. So let's talk about what's wrong today with our applications. If we look at the device-based applications that we were just referring to with the smart speakers especially and some of the other CPE in-home, I've put three categories together here. We're looking at different kinds of vocabulary, keyword and menu specific on the left, context-specific, and large vocabulary. And you'll see what I've shaded in red with the purple stripes are the application-specific, relatively low-cost, relatively low scalability applications that we all know and love today. But they are typically device-dependent, speaker-dependent for things like dictation, and location-dependent because they're typically in a building or in-home. And they rely on the cloud for much of their processing, which can often lead to high latency. So we have multiple dependencies, often a high CPU cost from the service provider point of view when they need to use the cloud, and often complex programmability for the user. What we really would like to see is the white spaces filled in with device-independent, speaker-independent, and location-independent capabilities. And that's what we're going to be talking about today. If we look at what those need to be, they need to leverage the network, and they need to bring in some minimal dependencies with lower CPU cost from the service provider perspective, natural language processing as needed with very fast response time, and a speech user interface that makes it much easier than programming your handheld device. So let's talk about specific applications that can go all the way from limited vocabulary key menus and context or speech-specific to large vocabulary-specific and even language-independent. We see a new opportunity emerging if you can meet the new requirements for service providers. Compute-intensive natural language processing at low cost, ubiquitous availability even in very noisy conditions, something that many of the voice call people have been very good at dealing with for a long period, and fast response time without speaker training, as well as new use cases that we see emerging, and those are some of the ones we're going to be talking about today, that can be device independent but personalized as needed. Hybrid voice and media content, where keyword-driven control can link to real-time device-independent speech translation. And device-originated policy that can actually control call triggers and other applications. I won't go through these, but we see a number of new requirements. The major categories on the right that can't be met with today's device and location-dependent devices relate to voice quality enhancement, which is a unique opportunity for the service providers, third-quality communications control for both application-to-person and person-to-person. And then there's several categories of service applications: speech-controlled applications, hybrid person and application-to-person apps, and voice is an integrated part of media analytics. So without more ado, let me hand it off to Al Belasco to talk about how Radisys sees some new opportunities and challenges. Al.
Thanks, Sue. So Sue has highlighted After, frankly, decades of niche appeal, both within and outside of telecommunications, the change and transformation in what's possible with speech recognition and advanced speech technologies really has been remarkable. Just a week ago, in its coverage of the annual Consumer Electronics Show, The Economist magazine declared that speech is invading everything. That was the dominant theme in its coverage of the event. This ubiquity extends beyond the consumer devices that CES is known for, that Sue touched on in her presentation, to a broad range of markets and applications. Just within telecom itself, until fairly recently, speech recognition, the context for speech recognition typically meant a touch tone application, IVR replacement. Today, with the advances in speech technology itself and the solution that Radisys is offering, we can enable speech applications that are used in communications service providers' networks, but that transcend those networks and cover over-the-top voice interactions, whether it's through a PC, a mobile device, using an over-the-top or VoIP connection, or a PSTN or mobile voice call to support person-to-machine interactions, person-to-application interactions, person-to-bot interactions. It's even possible to enable these capabilities for person-to-person interactions as well. So speech technology and speech-enabled applications can serve the requests of callers who are in conversations or even conference calls. Hey, I'd like to invoke the application through speech to record a conference call or to dial somebody else into a conference call. But to exploit this market opportunity and extend the reach of speech interactions to many more applications, communication service providers do need to overcome a few challenges. The traditional in-call speech solution has required the integration of monolithic and full-featured speech recognition engines, integration with other elements in the network like media gateways, external media servers, to adapt to various call quality conditions. Additional media grooming elements have been required to optimize the user experience and improve recognition accuracy. Just mixing and matching all these components and technologies was costly, or has been costly and complex, and limited the types of applications communication service providers have been able to offer. IVR and help desk systems have been a natural fit. Again, that IVR replacement use case. Why? Even with high cost, speech recognition could be used relatively briefly in those interactions to overcome limitations of touch tone menus, reduce the hierarchy and complexity of those menus, and help with data collection for callers for call routing decisions. But the cost in those cases was mitigated by the fact that those speech resources would be used only for a short duration at the front end of a call and then released. But a different approach is required to address these challenges and open the door to new communication applications. The challenge is the solution must be independent of device, like a specific phone or speaker manufacturer's platform. It must offer lower total cost of ownership to cost effectively enable more services, where the recognizer would be continuously and for potentially the duration of long calls processing speech. It must be fast, unlike a device sitting on a desk or a shelf where there are visual cues to the fact that the speech is being processed. When you're on a phone call, it's different, and time slows down in those cases. It must be able to overcome call quality issues and network conditions that are unique to telecom or telephony interactions. It must give the service provider the ability to leverage their own brand and even retain data for value and uses for analytics, so they can serve their customers and improve the the value of those applications. It must allow mixing and matching of speech technologies to best serve specific use cases. The new RateAssist Media Engine Advanced Speech Processing solution addresses these requirements. We support a combination of speech engines from wake word or keyword detection embedded in the software media server itself. This platform runs in off-the-shelf servers to server-based or cloud-based platforms from companies like Nuance, Google, IBM, and others. We expose a full set of media server capabilities and the speech recognition through a consistent set of APIs that allow the development of advanced applications that mix and match functionality to best serve users to enable more advanced applications and analytics. And as Sue mentioned, Adnan will cover a number of representative use cases in the next section. We also have integrated voice quality enhancements that can help improve the accuracy of recognition. So all these capabilities are combined, simplifying the deployment of the solution. APIs enable application developers to easily take advantage of these applications and mix and match and pick from best-in-class speech technologies based on a specific use case and not get locked into any individual vendor. So how does it address those challenges? It decouples recognition processing from any specific device. That extends the application reach and the ubiquity of an application. CapEx and OpEx costs can be reduced by up to 90% by using a combination of wake word and natural language technology, along with smaller hardware footprint that RateAssist requires. The ability to run the media server and use speech resources in-network versus depending on a public cloud for accessing speech processing can reduce latency and improve performance in applications. And I do want to stress the word dependence there. There are cases where cloud processing or a combination of cloud processing and service provider hosted technology makes sense. And again, in the end, it all depends on the use case, the performance requirements, the economics of a particular application. But the point is that with the RateAssist solution, the user can choose without any compromise. Integrated voice quality enhancements that I referred to earlier, these can reduce recognition errors by up to 20% in some scenarios, improving the user experience and further lowering service delivery costs. Some of these technologies, some of the speech technologies are priced based on usage. The less that a user has to repeat their question to get an accurate read from the recognizer, the lower the cost, the better the user experience. It also improves service providers or provides service providers the flexibility to leverage their brand, any unique persona they want to present as part of applications, and retain and leverage valuable data that can be used for customer analytics. So the RateAssist solution can help application developers and service providers improve the cost and performance of the traditional applications like IVR and contact center call handling. Don't want to trivialize the benefit for those use cases, but more significantly, it makes new applications viable. It can extend the capabilities of embedded device call assistance or personal assistance to in-call services. That's part of the white space that some of these technologies and consumer devices can't reach today. It can make bot interactions more natural and accessible, whether in an over-the-top or VoIP session or via a telephony-enabled bot. More and more users and application developers are breaking their dependence on native phone applications by using bots. That's why you see some of the statistics on this slide. That's why the rampant utilization of bots is significant. And this is just one reason why device-independent speech recognition that RateAssist and service providers with in-network capabilities, this is just one reason why this is a key enabler. And again, the RateAssist solution can also help developers drive down costs for some of these new applications. For example, for transcription services, where reducing error rates can not only improve customer retention, but dramatically lower costs. The typical number of errors in a page of text is about 50. In a telephony interaction where the transcription is happening over a call and where network conditions may be poor or background noise may be impeding the quality of the audio, that error rate can be even greater. In some of these applications, particularly for specialized vertical markets, there are actually humans that are used to post-process the recognized transcription to improve the rate. So anything, even small improvements in the accuracy rates can dramatically lower the cost of these applications. It can even help improve safety for mobile users in day-to-day applications by extending hands-free use of the phone to in-call capabilities, like, as I mentioned earlier, like invoking features in a conference call. So this new media engine speech solution is available today. I talked through what are significant benefits in terms of performance, cost, the ability to extend the technology and for service providers to offer new applications cost effectively. If you want more information, if you want to schedule a demo, or if you want to request an evaluation copy of the software or have an account to access online, please email sales@ratassist.com. That's RADISYS. And I'd like to hand off to Adnan now, who will talk more about some of the representative use cases that can be enabled by the solution.
Thank you, Al. So yeah, in the next section, what we'll do is go through some real-world use cases where speech-enabled technology that Sue and Al introduced. And we'll go through a handful of use cases where keyword recognition, or sometimes referred to as wake word recognition, while built into the media server technology that's already deployed in a number of carriers and enterprise applications, that can enable a differentiated set of use cases that to date have not been possible or have not been deployed yet. So a quick summary or recap of the key differentiators that I think Al was referring to as well. First of all, that it's an embedded solution. That means that the technology that we're describing here in terms of keyword recognition and associated speech recognition and analytics, it's built into the media server technology that's already deployed in service providers and enterprise networks. So hence reducing the overall cost of the solution, not necessarily in every use case requiring external servers and the cost and management of that external equipment. So it's reducing the total cost of ownership. The second key differentiator is that it's in-call. I think as Al was describing earlier as well. So in-call meaning that in any live telephony a call, whether it's person to person or application to person, and some IoT use cases as well that I'll describe in these use cases. So during a call, you are able to invoke, or the subscriber or the person in the call is able to invoke a keyword and then be able to direct the session according to the words and the keywords that are spoken. And lastly, this new technology is based on machine learning and inference algorithms, which is, from a technology perspective, a major differentiator as this technology has evolved. It's been around for quite a few years, but the technique used were mostly based on acoustic analysis, and hence there was the complexity in compute-intense resources, as well as the level of accuracy that could be attained using that technology. Versus now, where AI, machine learning, and inference is being applied, the breadth of applications and the accuracy and the amount of resources required is significantly different as opposed to what's been deployed to date over the last few decades. So with that, there would be, of course, as you can imagine, a very broad set of real-world use cases. We'll just focus on maybe kind of 3 different categories. We'll do a few use cases in each category so that hopefully we get an idea in terms of what are the real-world use cases that can be created using this keyword technology. So on the left-hand side, talk about some use cases where the in-call digital speech assistant or keyword detection can be employed in a peer-to-peer real live telephony or voice over IP call wherever there's a live communication session between two parties or a multi-party session like a conference. The second part would be while real-time speech transcription and some additional analytics information that can be garnered from the keywords themselves that are being detected, as well as the transcription of the speech into text and what additional information that can be of value to a vertical application. And lastly, we'll go through a use case around IoT. As IoT is getting deployed in LTE-M networks, where those IoT devices are speech-enabled, and how keyword detection and services can be created for that. So with that, let's start with a kind of a basic use case where there's a point-to-point or peer-to-peer call between Alice and Bob, as you see on the screen. During the call, if Bob has the keyword detection feature enabled, so we don't necessarily, or any operator will not necessarily enable that for every single subscriber, so that really depends on the deployment model. But if Bob has the services for speech recognition enabled as part of his subscription, then anytime during the call, Bob, when he says, "Hey, Sophie," and pick the keyword, every operator and service provider will pick a specific wake word that allows further interaction with the speech engine provided in the media server, as you see in the diagram. So when Bob says, "Hey, Sophie," the keyword recognition engine detected that, and now additional keywords can be spoken by Bob, and a number of different actions can be invoked during this live peer-to-peer call between Alice and Bob. So to give you an example, Bob may say after that, "Start recording," and the keyword detection engine will detect the keyword "start recording," and with each keyword, there can be a set of actions that can be associated with the application. So start recording will obviously make an audio recording that can be heard later or sent to somebody or shared with somebody. But in addition to that, start recording can also do a transcription of the speech interaction between Alice and Bob. And when Bob may say stop recording, and the transcription of that speech can then be subsequently sent in as an SMS reminder or notification to the parties involved in this two-party session. So as you see in the diagram, when Bob says start recording, and he might say at that point, "Meet tomorrow at 8 a.m." as an example. When you say stop recording, the action associated with that would be, as an example, to send an SMS or a messaging notification to the parties in the call. SMS notifications and other messaging services are, of course, not part of the media server, but there are APIs and interactions available through application logic that enable sending the SMS or message notifications once the speech recognition has detected or transcribed the audio. So these capabilities, as you see in the diagram, too many to list in one diagram, of course, but recording, keyword detection, obviously itself, and a number of pre-programmed or pre-created set of wake words, as well as a number of action words that the other party can speak during a live call. Moving to a multi-party session, so this would be a typical conference scenario where there's multiple parties connected into an audio or video conference call, and typically in a conference there's a moderator and a number of participants. So in this diagram, Alice is the moderator, so she will have additional as the moderator. So she can invoke this keyword recognition capabilities by, again, invoking the wake word. So in this example, again, the wake word is "Hey, Sophie." And when she speaks "Hey, Sophie," she has then, after that, a number of additional keywords that she can speak to control the the behavior of the conference. So she may say mute all, for instance, or she may say start recording, or any number of typical conference controls that can be invoked by Alice as the moderator. The participants themselves also can have the capability to invoke keyword detection. However, since they are not the moderator, they may have a different set of either the wake word itself or the set of actions that they are allowed to interact with the conference bridge as a participant. In addition to that, the participants themselves, so on the bottom left-hand side where John is a participant and he's attempting to join the conference bridge, prior to that he will have a typical IVR session. So certainly keyword detection will also enable or assist with the getting into the conference bridge by speaking a PIN or additional information about himself that can be recognized and be recorded as part of the participant joining the conference. Once authenticated, then naturally John would be joined into the conference bridge. An additional capability on the far right-hand side where Jack is, so Alice also has the ability to add user. And based on the participant list, she's able to identify a given user who was invited to the conference and be able to speak, add user, and identify the user, and the database associated with that will have a dial-out number available for him, and the network will place an out-dial call to Jack to invite him to the conference bridge. Kind of lastly, Bob, for instance, on the top right-hand side, since he's a participant and joined into the conference bridge, some of the feedback that we receive from some of our customers and partners, that if any of the participants wants to invoke the keyword detection, they have to say the wake word, of course. However, this may be a little disruptive in a conference bridge where people are constantly using the wake word and everybody else is hearing that. To do that more discreetly, Bob also has the capability to, instead of invoking the wake word by saying, "Hey, Sophie," that everybody would be able to hear in the conference bridge, Bob would be provided with or any participants provided with a short code that they can enter on their phone. So in this example, we're showing *77 as an example. That would be equivalent to Bob saying, "Hey, Sophie." At that point, Bob would be audio into the conference bridge would be removed temporarily, and Bob would be able to connect into the keyword portion only into the media server, and he can say additional keywords that would then not be heard by the conference bridge. So he might mute himself or take additional action, and at the end of that, he would be rejoined into the conference bridge. So a lot of different use cases, just only highlighting a few kind of typical conference multi-party use cases that are in call, meaning during a live session, is a set of keywords that can be invoked by the moderator and additional controls and actions available to the participants. Moving on to a typical contact center application. So here, I think as Al was referring to as well, typical contact center interactions can start with communicating with a bot, for instance. And going forward, these bots are not only text-based, and some of them are enabled with speech as well. So the user, John, on the left-hand side can interact with the bot by speaking to it. And the media server, as the audio is going through from between John and the bot, and if keyword recognition or wake word recognition is enabled, the media server, on detecting certain keywords or key phrases, is able to instruct the bot to send messages into the contact center in terms of what the user may be looking for and how to help redirect the call to the appropriate agent within the contact center. So if John says, as an example, he may be interested in upgrading his phone, he may have a technical issue, or he may want to review his bill, as some simple examples, by invoking the bot through speech, and then through the contact center, the appropriate sales agent or technical support or perhaps a billing agent would be connected now a live conversation now between John and the targeted agent. The agents themselves will have keyword detection or wake word available to them that they may be able to go in a sidebar, invoke keyword detection, and be able to maybe escalate the call, say add manager, and then a third party would get connected into the through the media server as a three-party bridge or a multi-party bridge on the fly. They may be able to go and add expert if somebody has a technical issue, or be able to do simple transfer of the call while the conversation is occurring. The sales agent determines that there's a billing issue as well, and based on the keywords that are being detected, the sales agent will get reminders of what the user is asking, above and beyond what the user is trying to explain, as additional reminders to the agent in terms of how to better provide service to the call-in party. So more interesting use cases kind of furthering into the contact center are really about advanced call analytics. So a couple examples in terms of what we mean by call analytics. And again, this can be broadly used in many different verticals. Just taking an example of a contact center here. So while John is in a session with either the bot initially or has been connected to a specific agent, during the call, the contact center may have specific promotions on behalf of their enterprise that they would like to highlight. So during specific keywords, so for example, if John is looking for a phone upgrade and he mentions upgrade, or he mentions iPhone, Galaxy, for instance, those would be the keywords. And as they're detected, the sales agent would have a notification sent to them through the application logic based on that keyword detection. And based on that, what the agent would say, if there's a current promotion that's going on, for instance, that during the month or during a special event, that would become immediately available to the agent as a reminder to go and describe that promotion to John as a reminder of what they may be able to benefit from. So those keywords triggered immediate recommendations would help with the overall satisfaction of the end customer support that John would be looking for, and additional analytics that can be generated in terms of how often a user was interested in a specific topic. In addition to the kind of the live reminders or additional information that either of the agents is able to draw the user's attention to based on the keyword or key phrase that the user had spoken. So at the bottom is the analytics aspect that over time it takes contact centers enormous amount of post-processing and looking at perhaps hundreds of thousands, if not millions, depending on the size of the organization or collectively, to draw some additional inference from the collected data from an analytics perspective. To be able to sort through that in real time so that the information that's being gathered and collected by the customers that are calling into the contact center allows that information to be recorded in a data lake for post-call actions. So that would be the initial keywords or key phrases that are spoken, the frequency of them, in what context they were spoken, as well as the ability to be able to transcribe the session as well, so that performing some post-call analytics on that thing allows better inference and better service going forward in terms of how the service that the contact center is providing can be fine-tuned all to get better, of course, customer satisfaction scores and overall improved service quality to the users. Moving forward, so there's another aspect of analytics, what we refer to as advanced call analytics related to sentiment analysis. So based on, again, machine learning and inference combined with pitch and tonal analysis, the ability to be able to detect the sentiment of the user. So this is kind of goes above and beyond a keyword or key phrase detection, and through that analysis, the ability to determine the sentiment of the user. And that's quite important because just collecting, not just collecting statistics, but also being able to live notify an agent where they may not have picked up on that, of that sentiment that either the user is either agitated or he's somewhat not happy or angry, or the call is going normal and things are going okay. Just a basic set of sentiment analysis notifications to the agent can be very important. You would expect that the agent would pick up on that, but in many cases, you'd be surprised that maybe a reminder would be something that would be helpful, where the agent can either then involve a manager or some additional support, or to be able to provide the user with some additional information. As well as we talked about on the previous slide, the classification of the type of calls would say what percentage of the calls have already been kind of pre-sorted into the analytics engine in terms of which customers were clearly perhaps agitated or needed additional information that was unsatisfactory based on the sentiment analysis, and to have a follow-up with them without having to go through all pre-recorded recorded calls and then post-determine that, which can take an enormous amount of resources and time, and to be able to then identify a handful or a small percentage of calls that actually required further action. So switching gears here a little bit in terms of we talked about so far, typically person-to-person, in-call, peer-to-peer, or multi-party, or certain verticals like contact centers, and some analytics that can be applied to the keyword or key phrase that are being detected, plus the speech recognition into text and during the call, as well as post-analysis that can be applied to it. But it is not limited to that. As you probably, most of us on the call realize, that IoT devices, as they're becoming more prevalent in the industry, certain IoT devices, typically LTE-M or otherwise referred to as Cat-M1 devices, that are speech and video capable, and have the ability to place an inbound call over a VoLTE network. So in this case, a couple examples here, where there's some IoT device, whether that's a wearable of some sort, or perhaps a sensor or a surveillance security type of an IoT device. As it has local sensors, and that may be depending on the IoT device, what sensor within the device triggered the IoT device. And based on the logic and what it needs to do, the IoT device may initiate an inbound VoLTE call into the network. And while doing that, it will enable its local embedded microphone and/or camera if it's also video capable. So as the IoT device automatically places an inbound call into the network, it enables this microphone, and the audio that in the surrounding area to the IoT device is the audio that will be placed into the network in a live session. So that audio and/or video, in some cases, if the IoT device, as I mentioned, is video capable as well, the media server logic will receive the audio and is able to detect keywords or key phrases that are being heard in the surrounding area of the IoT device. So some typical use cases may be that a smoke detector or some other sensors that triggered the IoT device. The IoT device places an inbound call, a VoLTE call into the network, and the media server is now receiving a live RTP feed, live audio or video feed into the network, and keyword detection is being enabled, or key phrase detection is being enabled in that. So if in the surrounding area, the word, for example, fire or gun, or perhaps call 911 is heard, the logic in the media server, having detected that, along with the application server logic, can take any number of specific actions. And those could be to automatically dial out and connect the operations center, that may be the building manager, or perhaps emergency response team, or local factory manager, for instance, if it's an IoT devices that are being enabled within a factory automation type of a scenario. So automatic dial-out and bridging in the parties that should be aware of this live event that triggered the IoT device, and there's an audio and/or video stream coming in from that device, can then be viewed or heard on their mobile handsets or the equipment that they got dialed into. So in the example on this screen, as you'll see, the IoT device was triggered based on a local sensor. It placed an audio and video call of its surrounding. The three operations staff from the team got auto dialed out. They automatically got bridged into let's say a conference between the three of them. And the screen that you see towards the bottom there is that they're able to now have a live three-party call session between them. And as well, they're able to hear and see what the IoT device is sending to them. So this is kind of one example of where IoT devices, which are audio and video enabled, have the ability to be able to have keyword detection or phrase recognition enabled on them, and very specific actions can be taken kind of above and beyond as simple as making a recording of a session. If somebody said a keyword, now that's an important call, and you may simply just want to transcribe the audio, or just maybe simply record the audio, because it's not possible to record the audio anytime a trigger goes off. So only based on certain keywords or key phrases, a recording session may start, or as sophisticated as a multi-party session can be auto-initiated and recorded, and a live audio and video feed can be seen and heard by the operations team. So I think with that, I will hopefully I'll give you some idea in terms of some real-world use cases that we've deployed. As I mentioned earlier, there can be obviously a very broad range of use cases that can be employed in very specific vertical markets. But hopefully that kind of gives you an overview in terms of where in-call speech recognition is being used today. So with that, I'll turn it back to Sue.
Thank you very much indeed, Adnan. And with that, let's turn to the Q&A. We have a little bit of time, and we have some questions. You can still enter more questions if you click on the Q&A button at the bottom of your screen, or if you'd like to download the slide deck, please check the resources list at the bottom of the screen. The bios of our speakers are also on the right side of your screen. So let's start with the first question. We have a question that asks, Al, what speech recognition engine is integrated into your media server? Is it a Radisys engine or a third party?
Thanks, Sue. Start with the second question first. So our goal with this solution is to provide support for a range of best-in-class speech technologies, as I mentioned earlier, whether they can be deployed and supported integral to the media server, in network, in conjunction with the media server, or externally in a public cloud. So the range of technologies we support are all third-party technologies. The engine itself that's integrated into the media server, it's probably more apt to say engines. So we've created a framework that allows small footprint, wake word detection engines to be plugged in and exposed behind the same APIs. To date, we have integrated 3 platforms. Due to contractual reasons, I'm not able to disclose them here on the call and publicly, but under non-disclosure, we can. So if somebody's interested in this further, we can follow up and have a discussion about the specific technologies under NDA.
Great, thank you, Al. Adnan, one of the other questions is what's the expected degree of accuracy of word detection, and how important is the language accents and variations? Do you handle those with the same detection accuracy, or both of you, whoever wants to answer?
Sure. Yeah, I can perhaps start with that. So as I was mentioning in the earlier section, that this technology is based on machine learning and inference. versus in the past over speech recognition is obviously not new, but the technology behind it was quite different based on acoustic analysis, and that had, of course, its performance and/or accuracy issues. However, with this, the differentiator here with this new technology being based on ML and inference algorithms, the level of accuracy can be significantly improved. And relatively, in relative terms, lower amount of compute power as well. But coming to your question around accuracy, so the accuracy really will then depend on the amount of machine learning and the number of samples that are used for a given set of keywords or key phrases. And that includes, people that may say the same word with perhaps an accent or as a second language. They may, or maybe if there's background noise and they were saying the word. So the larger the machine learning algorithm, the higher the accuracy. And to date, to give you some examples, a rough idea, it's only 95% or higher. We don't consider anything less than that to be technically feasible. So the target is certainly above 90%, and in many cases, with sufficient amount of training, could be over 95%.
Great, that's really good. We have a couple of related questions. One person is asking, is there a copy or version of the engine that can be downloaded for testing? Or another question, that is there a managed service or some online version that service providers can trial? I don't know who would like to answer that one.
If I can answer, Sue, thanks. So both options actually are available. We can make available a copy of the software and the package with the media server and integrated speech recognition technology. We can also make it accessible remotely in a cloud. We can arrange for demonstrations. So as I mentioned earlier at the close of my presentation, please contact us at sales@rateassist.com, and we can arrange to share more information and make whatever the best access to the platform is suitable. We can make that available to anybody on the call.
Do you have anyone that you want to talk about? Do you have any trials ongoing currently that can be talked about?
Yeah. So we have actually several application developers in our ecosystem who have built applications or have been building applications with pre-release versions of the software. A company called Agnity, for example, they're an application developer that serves the telecommunications space, and they're based in Northern California. And we have several other OEMs, much like the integrated speech. Under non-disclosure, we can provide more details on those companies. And now we have a GA version of the platform that's accessible, and we can connect interested parties to those ecosystem partners, or if they're developers themselves and have a unique application, we can provide evaluation access to the software.
Cool. I have a separate question on how does this work with other media server platforms or other call platforms. How does an operator provision this platform? Does it become an integrated part of their service enablement capability, or does it require separate orchestration? Or is it different for the IoT cases than it is for the in-call contact center and so on?
Yeah, perhaps I can take that one to start with. So yeah, the deployment models for enabling this technology, there's perhaps many different ways depending on the actual use case. So ultimately, I think as some of the participants on the call have media server technology perhaps already deployed in their network, whether it's an enterprise or a service provider. So the media path is what needs to be accessed, obviously, to be able to enable keyword or key phrase detection. So that can be deployed at the edges of the network where you have peer-to-peer sessions, audio sessions going through, or it can be deployed as part of service logic integrated with an application server that will actually create the end use case for the target application. So it can be under the control of an application server that provides the application logic, or it can be also deployed at the edges of the network where a certain number of calls are being directed through inline through the media server technology, and the keyword recognition or key phrase recognition can be enabled, and appropriate notifications can be generated from that. In the IoT use case, I think as you asked as well, so similarly that can be deployed at the edges of the network, or can be centralized within the service providers' data centers.
So do you see the solution scaling down to be part of an edge service?
Yeah, absolutely. So I think we see that some of these services, particularly the IoT space, are very critical to latency-sensitive applications, more particularly maybe in the video, but also in the speech domain as well. So the scalability of the solution is critical for those type of applications where they not naturally suited towards more of a centralized, or perhaps as Al was describing earlier, even in a cloud deployment. So the scalability can scale the same technology. The footprint can be scaled to a very small footprint that can be further out into the edges of the network on general purpose compute infrastructure with hardware acceleration when needed to provide higher densities, and it can scale to a very large scale when it's more centralized.
Great. We have a follow-up question on the language question. Which languages are already enabled in the current trials you've been doing for the recognition services?
So with this, I'll start, Adnan, you can layer in. So with the range of technologies I mentioned, we've integrated three platforms. I think there's at least a couple of dozen languages supported across all three out of the box, and through different techniques, training and extensions within a short time frame, additional words or vocabularies can be supported in other languages as well. We can follow up, Martin, with the full list of languages supported.
Great. So I think that's pretty much all the time we have for questions today. I would very much like to thank our speakers, and you can, again, download the resources. From the resources button, you can download the slides for the presentation. So thank you to both Al and Adnan for a great presentation today, and this is a really exciting area. I'm sure we'll be hearing a lot more about it. Thank you very much indeed, and have a good day.
Thank you.
Thank you.
Okay, thank you everyone for attending this Fierce Markets webinar and for submitting so many great questions. I would like to thank our speakers for participating and Radisys and Strategy Analytics for presenting today's webinar. This webinar has been recorded, and you will be able to access the recording within 24 hours using the same audience link that was sent to you earlier. Thank you again for joining, and we look forward to seeing you at future events.